Hi, this is Jeline from the Honors Tutorial. Welcome back to part 3 and the last part of our topic, which is about multiplication of radicals under Mathematics 9. Let us have the continuation of our examples. Now we are in example number 9. So we have here the square root of 3 times the quantity of square root of 8 plus 4 square root of 5. And this is what we are going to do. Let's write the solution here. And then let's distribute square root of 3 to each of the terms inside the parentheses. So let's start with square root of 3 times square root of 8. So square root of 3 times square root of 8 is square root of 24. And then we have to distribute square root of 3 to positive 4 square root of 5. So square root of 3 times 4 square root of 5 is equal to plus 4 square root of 15. Because we will just copy 4 and then multiply 3 and 5. And then after that, we have to simplify square root of 24. Kindly factor this and think of a number or numbers that when multiplied is equal to 24. But please take note that the first number should be a perfect square number. So we can use 4 because 4 is a perfect square number times 6 plus 4 square root of 15. Square root of 4 is 2 and 6 will remain inside the parentheses plus 4 square root of 15. So this is the final answer. We cannot combine it because they are unlike radicals. Let us have another example. So that is example number 10. So we have here 3 square root of 2 times the quantity of 3 square root of 12 minus 2 square root of 7 plus square root of 3. So let us distribute 3 square root of 2 to all of the terms inside the parentheses. So let's have this first. 3 times square root of 2. 3 square root of 2 times 3 square root of 12. And then minus 3 square root of 2 times this second term, 2 square root of 7 plus 3 square root of 2 times square root of 3. So let's simplify. So 3 times 3, that's 9. And then 2 times 12, that's 24. Minus 3 times 2, that's 6. 2 times 7, that's 14. So square root of 14. Plus 3, copy 3, square root of 2 times 3, that's 6. We are not yet done with this example. We have to simplify square root of 24 because there's still a factor of 24 that is a perfect square and the other one is not. So we have here 9 square root of 4 times 6 minus 6 square root of 14 plus 3 square root of 6. So that's 9 times square root of 4, that's 2 square root of 6 minus 6 square root of 14 plus 3 square root of 6. We are not yet done. Let's continue solving this. So now we have here 9 times 2, that's 18, square root of 6 minus 6 square root of 14 plus 3 square root of 6. Now we can see here that we have here now like radicals. We have here 18 square root of 6 and 3 square root of 6. We can combine them because they have the same index and same radicands. So 18 plus 3, that is 21. And then copy the square root of 6. And then minus 6 square root of 14. We cannot combine 21 square root of 6 minus 6 square root of 14 because they are unlike radicals. So therefore, the final answer is 21 square root of 6 minus 6 square root of 14. Let us have another example. We have here this square root of 4 plus 2 times square root of 4 minus 1. So in this process, we can have the FOIL method, or we can just simply simplify this. Um, let us have the shortest and easiest way of solving it. So solution, let's copy the given. So that is square root of 4 plus 2 times square root of 4 minus 1. So square root of 4 is 2. So we have here 2 plus 2. And then square root of 4, that's 2 minus 1. 2 plus 2 is 4 times 2 minus 1, that's 1. 4 times 1 is 4. So this is the final answer. It's 4. Let us have another. Example 12. This will be the last example for this topic. We have here the quantity of square root of 3 minus 7 squared. And this is how you are going to solve for it. Let's expand this. It will become the square root of 3 minus 7 times square root of 3 minus 7. And then you know FOIL method. Let's apply this. So f is for the first term. So that is square root of 3 times square root of 3. So that is equal to square root of 9, and that is equal to 3. Because square root of 9 is 3. And then O for the outer term. So that is square root of 3 times negative 7. Square root of 3 times negative 7. And that is equal to negative 7 square root of 3. And let's have the inner term. The inner term is negative 7 and square root of 3. So that is negative 7 times square root of 3. So that is negative 7 square root of 3. And then L, last term, that is negative 7 times negative 7. So we have here negative 7 times negative 7. That is equal to positive 49. So as you can see, for O and I, we can combine them because they are similar radicals or like radicals. So in this case, we can combine negative 7 and negative 7. Then it will become negative 14, and then just copy square root of 3. So what is our final answer now? The final answer is 3, copy F. So that's 3 minus 14, this one, square root of 3 plus 49, this one. And then we can combine 3 and 49 because they don't have radicals. They are simply whole numbers. So 3 plus 49, so that is 52. And then minus 14 square root of 3. This is the final answer. Though we cannot combine 52 and 14, we cannot subtract them directly because 14 contains a radical. So therefore, they are unlike radicals. So we cannot combine them. So that's it. This is the third and the last part of our topic. I hope that you have learned something today from part 1, part 2, and part 3 of this topic. If you have inquiries about us, please contact the Honors Tutorials page. That's it, and thank you. God bless.